Hello, this is Alex Howe with the Science Meets Fiction Exoplanets Review, April 1st edition. And yes, I know April is half over. I've been busy, and also I forgot there might be a bonus video worth making for this. I'm going to try to do it in a more timely fashion if I'm still doing this series next year. If you follow scientific news on a regular basis, you may be aware of joke papers and parody research. Whether it's the Ig Nobel Prizes, which award prizes to the silliest-sounding real research every year, or Isaac Asimov's fictional papers about the time-bending molecule thiotymoline, scientists do like a good joke. In astronomy, it's customary to publish joke papers to the archive preprint server on April Fool's Day, and there are always at least a couple of them about exoplanets. Although sometimes they cause a glitch in the system, like this one was mistakenly labeled a COVID paper, presumably by Archive's algorithm. Anyway, I wanted to take a minute to talk about this year's batch. The first one is Social Distancing Between Particles and Objects in the Universe. And this paper essentially compares how far apart socially distanced humans are versus other objects in the universe, from atoms in solid objects to neutrons in a neutron star, all the way up to stars in a galaxy. There's no real finding here. Humans are in the middle of the pack because we couldn't really be anywhere else, but it's a fun graph to make. Next up, an homage to all the Zoom meetings we've had over the past 2 years. First detections of Exo-Pets, observations and follow-ups of the floofiest transits on Zoom. And this is a very scientific-looking analysis of transits of pets on Zoom calls, looking at things like light curves, analyzing them in terms of exopet length, transit duration, and of course, floofiness, and even breaking them down into subcats, cats, and supercats. Apparently, cats are much more popular than dogs with astronomers. This next paper, The Parking Lot Planet, asks a seemingly random question of what if an entire planet could be an amusement park. The problem with this, the authors say, is that a typical amusement park needs to have a parking lot about the same size as the park. So you would need to have another planet to be the parking lot. And this paper essentially looks at what properties a planetary system would need to have in order to have a second nearby habitable planet that could serve as the parking lot. A lot of these papers make more sense if you actually read them out. Anyway, this was an interesting one. Cows All the Way Down, Cowshed 1, Could Cow-Based Planetoids Support Methane Atmospheres? And they really went all out with this one, making it look like the first paper of a series and a paper about some kind of survey. But it actually asks a question that was apparently inspired by comments made by Jeff Bezos for reasons that even the authors don't remember, according to the acknowledgments, which is, could a planet or planetoid made entirely of cows support a steady-state methane atmosphere from the methane emissions of all those cows? And they looked at masses of planetoids and methane emissions and mass loss rates from low gravity, solar wind, and whatnot, and they found a range of parameters where it turns out it works. A planetoid, maybe even as small as our moon, made entirely out of cows, producing methane at the usual rate for cows, could sustain a methane atmosphere against astrophysical mass loss processes. So that was a fun result, considering I study atmospheric mass loss myself. Transmogrifiers, Bright of the Exomoon, has nothing to do with transformers. Instead, it looks at the very understudied astronomical topic of lycanthropy. Essentially, the author looks at the properties of our moon and considered which exoplanets could have moons that are similar to ours in certain important ways. And while we don't know of any exomoons around rocky planets yet, the author determined that the exoplanet LHS 1140b is the most likely to have a moon similar to ours and therefore to be populated by werewolves. And finally, we have this one, on the possibility of discovering exoplanets within our solar system. Of course, by definition, exoplanets are planets found in other solar systems. But the premise is that the number of known exoplanets, which just passed 5,000 last month, has been growing exponentially as we develop better and better ways of detecting them. And the authors say that if we continue this exponential trend, the number of detected exoplanets in our galaxy will be so high that we will be statistically likely to find one in our own solar system in the year 2146. And how could you find an exoplanet in our solar system? Well, they suggest at the Lagrange points. So those were the fun new exoplanet papers posted on April 1st. I do still have the regular March Exoplanets review lined up, so hopefully I'll be able to get that out next weekend.